It's glad to share our work InstructNav, a zero-shot system for generic instruction navigation in unexplored environment. Embodied navigation is a crucial skill for home assistant robots. Currently, there are mainly 3 different types of navigation tasks, including object navigation, vision language navigation, and demand-driven navigation. Most prior works can only deal with one type of those problems, because they often require in-domain training or task-relevant strategy, like building the frontier map in an object-searching problem. But in human daily life, the language instruction may not follow a specific format. Therefore, we think it is important to build a generic navigation system that can support multiple navigation tasks and any type of navigation instructions. Our proposed InstructNav is a training-free system, based on the large language model and large vision language models. It can take in any type of language instructions and translate it into a robot actionable trajectory. Concretely, we design a dynamic chain of navigation module and multi-sourced value maps. The dynamic chain of navigation module is responsible for unifying the planning process of different navigation tasks, and it predicts a navigation action and a landmark iteratively. The multi-sourced value maps will translate the planning results into a cost map for every point cloud, and then an integrated cost map can be used for robot path planning. Here we provide a detailed illustration of how InstructNav works. First, as the robot continuously receives RGBD observations, the robot will estimate its location and build a semantic point cloud map in real time. Then, our method will based on a panoramic image and the map information to make plans. The dynamic chain of navigation plans an action and a landmark. A vision language model is utilized to choose the best direction. Then, all the planning results will be translated into different types of value maps. Finally, the multi-sourced value map is generated and can be directly used for robot path planning. Then, the robot will follow the generated path to arrive at a waypoint and start another round of planning. Our InstructNav effectively grounds the common sense reasoning and spatial understanding abilities from large models into the navigation process. As this process continues periodically, our InstructNav can successfully achieve long-horizon exploration tasks, like finding the toilet. We also evaluate our proposed InstructNav in a real-world robot, TurtleBot 4, and we find our approach can successfully drive the robot for different navigation instructions in a diverse environments, including apartment, office, library, and so on.